Hello everyone, welcome to another lecture of linear regression. And today we will actually see that how we use uh, gradient descent actually and how we actually use it mathematically. Okay, so what happens in algorithm and when we code actually that it actually gets into code in the libraries that make easier for us. Now we will understand actually what maths behind it. Okay, so first we will take a quick revision that what we have done so far. Okay, what we have done so far. Now, so we had some data. Okay, we had some data and we made a prediction on it. Okay, we made a prediction on it using our hypothesis function, using our hypothesis function, which was nothing but beta 0 plus beta 1 x. Okay, this is our hypothesis function will be summation of beta. Okay, which was nothing but y hat. Okay, y hat beta 0 plus beta 1 x. Okay, we got this prediction. Now, what we did actually, we found this MSE mean square error. Okay, mean squared error. Get this. And now, what we want actually that we want to minimize this mean square error. We want to minimize this mean square error for the better prediction. Okay, for our better model to get the best fit line, which can actually predict the best values to make the best prediction. Now, for minimizing the MSE, which is nothing but it is actually a cost function. Okay, for minimizing the MSE, we used gradient descent. Okay, we used gradient descent, which is nothing but an algorithm, an iterative approach for getting the best betas. Because on which parameters does our prediction matters? Beta 0 and beta 1. Okay, x is the input actually. Whatever input we will give, it will give us the output. What is the main parameter that we have to actually focus on, which is beta 0 and beta 1. Okay, we have to mainly focus on this, and we have to optimize this in a way that uh, we get the best parameters and numbers for them. Okay, now this is for this approach we did actually that we had a cost function. Okay, we had some cost and here we had the beta and beta 0, and we have to get the best, okay, the minimum error. Now what it was actually, so let's get on this. So what was our MSE? What was our MSE? Also use h of x, it doesn't matter. Okay, now we have to optimize this thing in a way that we are getting the best beta and beta 1. Okay, we are getting the best beta 0 and beta 1. Okay, for that what we will do, we will use the gradient descent. And what is the actual formula for the gradient descent is, okay, yeah, so we have to find the gradient descent. Okay, so gradient descent use nothing but the calculus. Gradient descent uses calculus. Calculus. Okay, in which what we do is and for this we have nothing but we did okay sigma from 1. Okay, we will use 0 1 0 then position but okay, now what we will actually is that we will actually generalize not this we will okay, what we will okay, now what we will do actually is that we will do this y okay y minus y hat I squared. Okay, this is our MSE. If you see it, then this is our MSE for both beta 0 and beta 1. Okay, this is our MSE for beta 0 and beta 1. And now we have to use calculus and we have to find the best beta 0 and beta 1 for this. So what we're doing here is actually is that, so the derivative of MSE, okay, and with the derivative of beta I, okay, 0 to 1. Okay, we had for the beta 0 and 1. Okay, we can do this, or we could say it is same. Okay, we can use this beta, okay, theta for 0 and I, 0 and 1, this beta I. Okay, we won't use theta. Why the hell I am using this notations? Okay, we will use I, 0 till 1. Okay, okay, why? Yeah, Just it's writing mistake. Okay, are you getting what I'm trying to say? For I, we'll do I for 1 from 1 and 0. 0 for beta 0 and beta 1. Now this is the approach we have to understand is that what is happening behind it. Okay, what is happening behind it. And this is for the, for getting, getting the betas, getting the betas. Now we have to update this also. We have to update this also. Why? We have to update this, and how we will update this? We will use beta 0 before updating beta 0 minus alpha. Alpha is nothing but the beginning. In the example that how do we use alpha? This by by this, okay, we will update the beta 0, and for the beta 1 minus alpha, this beta 1 okay, we will update this. This is for updation. This is for updation. Okay, now we have to understand is what is happening behind this. Okay, this is for getting the betas and this is for updating the betas. Okay, now let's get this what is happening behind this. Okay, so we are in the journey. Let's get into okay, journey. Why the journey? Okay, now what we're doing, let's understand for only a single beta, you would understand for the both. Okay, now what is happening here is for the beta 0, okay, and derivative of beta 0. Okay, now what this says that how much this changes if we changes this. Okay, how much MSE changes this function if we change this one parameter. Okay, how much does this affect on it? how much how much does beta 0 affect on j of beta 0? This is what is telling me. Now what we know here is actually is that this function. Okay, what is this function? It is nothing but 1 by n. Okay, sigma from the 0 till the n. Okay, yi minus y hat. Okay, squared. Right? Do we have any problem? No. We know that. Okay. Now, what we have to do there is here is actually is that we will apply chain rule. Okay, we will apply chain rule because we are using the calculus, and we will apply here the chain rule, and we will find the the derivative of it. Okay, we will find the derivative of it. Okay, so for this what we will do here is, okay, what we will do here is actually is that if you don't know the chain rule, if you don't know the chain rule, if I tell you, then I know that I would be it would be better that you would be knowing the chain rule what it is, and if you don't know then you could go and watch wait go and watch the videos of Nancy Pi, and I will tell you a little bit of chain rule in it. Nancy Pi, the chain rule. I will link the video. I will link the of her videos in the description. Okay, for your ease. Okay, you can go and watch this lecture. She explained very well. Now, what we are doing here is actually is that we applied chain rule. Okay, and what happened in the chain rule is that, okay, but we can also expand this further because we had also this, so we will expand this in this form like this. What was this? What was this? Again repeated. What was this? It was nothing but beta 0 plus beta 1 x. Was it? Yeah, it was. Now we will also expand this. Okay, 1 by n beta 0 1 n yi beta 0 minus beta 1 x squared. Okay, squared. Now we have to apply chain rule in it. Okay, we have to apply chain rule in it. Now, if you don't know what chain rules looks like, now I can tell you what. Okay, so let's understand the chain rule. The chain rule. Okay. Suppose that we have a function. We have a function something as 4x plus 6. Okay, power 5. Now we want to find the derivative of it. Okay, we want to find the derivative of it. How will we do this? It is y. How will you find the derivative of y with respect to the x? Nothing but what we'll do here is actually is that we will first find the derivative of the this function, okay, the whole function, this whole function. Then we will find the derivative of this function, derivative of this inner function. Okay, so what we will do here is derivative of outer function into derivative of inner function, derivative of inner function. So what is the derivative of outer function? Let's find it. Okay, derivative of outer function is nothing but we know the power rule. Okay, we know the power rule. What happens in the power rule is that the power comes in the front, okay, into 4x plus 6, okay, and the power reduces by 1. Power reduces by 1, which is 4. Okay, we know till now. Okay, what happened actually that we brought the power in the front of the function, okay, into the function its power minus 1, okay, from the 5 to 4. And what is the inner function? What is the derivative of inner function? Now if we see the derivative of inner function, it's nothing but how much this changes when x changes. Okay, if we find the derivative of this function, it was 4x plus 6. Okay, derivative of this by derivative of x. So we know that how much this changes. How much this changes? So derivative of 4x is nothing but 4 for this, and derivative of 6 is 0. Okay, derivative of a constant is 0. Now what this derivative of this function is? So derivative of dy by dx is nothing but 20 into 4x plus 6 by to the power 4. Okay, what it is? 20 into 4x plus 6 to the power 4. It was its derivative. Now same happened here. Same happened here. What is the derivative of this function? What will be the derivative of this function? It is nothing but the derivative of whole function, the derivative, of this whole function into the derivative of this inner function. Okay, derivative of this inner function. So what we did actually here is, let's do here. What we will first do that we will bring this 2 from there to in the front of the function. Okay, any problem? No, we don't. Now what we will do here is y minus beta 0 minus beta 1x, okay, into the derivative of inner function, the derivative of inner function with the respect to beta 0, okay, with the respect to the beta 0. Okay, now what we'll do here is that yi beta 0 beta 1x. Okay, what is the derivative of it? What is the derivative of it? It will be nothing but, does it affect on y1? Beta 1 is affecting on this? No. What is the derivative of constant? Nothing. Zero. Zero. And we are here is also doing 0. So you think the derivative of constant is 0. 0. 0. Okay, it's nothing, it's actually 0. So we don't have any thing to do with the beta 0, because beta 0 is not actually affecting it. Okay, beta 0 is actually not affecting it. But no, it's wrong. I was actually making you fool. See, what is happening here is that we have beta 0. We have beta 0. Okay, and how much that is affecting? How much does it get affected? First, first. yi, it does not, the constant is 0. In this, what we have? We have minus, you could see, for this, we have minus 1 into beta 0. So, what will happen here is actually, is that, see, what will happen is that, it is getting changed by minus 1. Okay, it was in beta 0 and it is now minus beta 0. Okay, and what we find in calculus actually, that we find that how much how much y changes when x changes, and this is how it changed, and it changed by how much? Minus 1. So we'll do beta's y1 this into minus 1, because it is actually for it is constant. Okay, for it, if we can say that it is actually constant, so its derivative will be 0. Okay, and for this one, minus 1. Why? Because it is getting changed by minus 1. We actually did for beta 0 and it is actually minus beta 1. So it is getting changed by minus beta 1, minus 1. So we will do, so what is the derivative of this? Is nothing but minus 2 yi beta 0 minus beta 1x. Okay, this is the derivative of it. Okay, so what is the derivative of j beta 0 with respect of beta 0? It's nothing but minus 2. Okay, wait, I forgot this. Yeah, it is nothing but minus 0 1 by n. Okay, sigma from 1 to n. Okay, yi minus beta 0 minus beta 1x. Okay, did we have any issue in it finding it? No. Okay, we did not. Do we have any issue? No. Okay, so the final here is minus 2 by n 0 this by beta 0 this. Okay, this is the derivative of it. Now for the same, what we will do quickly for we will take our power to in the front of the function yi beta 0 minus beta 1x. Okay, into what is the derivative of it? Now we have to get the derivative of it. Now what is derivative will be? It is constant. Okay, what actually the input here is that for that what our function is changing, for which parameter does our this j of beta 1 is changing? For beta 1, and what is the beta 1 getting changed by this? By this. Now this is actually constant for it. This is actually constant for it. So what is the derivative for the constant of what is the derivative of constant? Nothing. 0. 0 minus what is here? Actually 0. And what is here actually? This is the game changer. What is here is actually s minus x. Minus x. So what is the derivative of this is in respect to this is nothing but 0 beta 1. Okay, derivative of this beta 1 is minus 2 by n. Okay, sigma 1 till n yi minus beta 0 beta 1x. Okay, into minus x I for the every ith value. Okay, so we have got in this video what we got, that derivative of beta 0 with respect to beta 0 is nothing but minus 2 by n sigma from 0 to n. Okay, y minus beta 0 beta 1 x into nothing. Okay, and for the beta 1 what we got is that this minus 2 by n this 1 till n yi minus beta 0 and the beta 1x into minus xi. Okay, now for this video I'm closing it down right now, and we'll be seeing in the next lecture how will we use this function actually, this function to get to minimize our cost function using the gradient descent. So thanks for watching till now guys, and I'll be seeing you in the next lecture. So thanks for watching till now. Bye bye.